Hello everyone, welcome back to my channel. Today in this session we are going to talk about database integrity constraints. One of the most favorite topics of examiners nowadays because it is a very important part of SQL queries. And somewhat people get confused with some of its portions. So I am going to try to make it simple for you. So let's start with it. So integrity constraints, first of all, what is the meaning of these constraints? What in general do they do? And what are the different types of integrity constraints, their representation? Discussing them with examples is what we are going to target today. So let's start with it. First of all, the constraints are some kind of checks or conditions which we apply on a relational table. Okay, so objective is what then? Why do we apply these constraints, right? So the objective is to ensure that the changes made to the database by authorized users do not result in data inconsistency. What I mean from it is that it should not happen that once a change is made to a database, it reaches an inconsistent state. What is data inconsistency? We've already talked about. If you want to recall it back, you can just check out my previous video, which I'll link in the description box below. Okay, so first of all, when I say this definition, uh, it specifies that it is only concerned with authorized users, because we assume that unauthorized users are not given the access to the database, and we are not concerned about what unauthorized users do. So basically we are considering a normal scenario wherein the database is being handled in right hands. Okay, now changes are being made because when a database is created, you first of all create a relational table, let's say, then you start inserting data into it. So you start inserting records, creating more tables and so on. So in this process, these constraints make sure that it should not happen that you try to insert a record which should not be inserted in the relational table. So that kind of thing should not happen. Like let's suppose uh, I try to enter a value, say age equals to 15 for a person. So let's suppose we are considering we were creating a database of people who can vote. Okay, we were creating a record of people who can vote. Okay, let's write it down. Let's say we were creating the records of voting people. So the relational table could briefly comprise of voter ID, name, and age, and city. Okay, now uh, first of all, what are the some of the things that you would try to avoid while data insertion or deletion that should be taken care of implicitly? For example, the age should be more than 18, right? 18 years or above should only be allowed to vote. So if I am trying to enter the record of a person who is of age below 18 or age lesser than 18, then the database should prompt a message that such kind of record cannot be inserted because it violates this condition, and that data entry should be avoided, right? Similarly, I cannot insert a record with a null voter ID, right? So I cannot insert a record with a null name, right? And so on. So this is a very broad example, a very generic example of what we mean from integrity constraints. What do they what is the objective of creating integrity constraints? Okay, now let's see some more examples from the book. So we have A savings account must have a minimum balance of rupees 5,000. Now, this can also be an integrity constraint which an account manager may think of applying, like if the bank has the minimum balance limit of rupees 5,000 for savings account, then they can just put this as a constraint in the database, because what will happen when they'll put this is that it'll help the employees, the person who is doing the data entry of entering the records of people who have created the savings account, that um, whenever the person tries to enter the record of a person who has minimum balance of, let's say, 4,000, the entry will not be allowed from the database end, because there'll be an error diagnostic will be generated stating that that kind of data entry is not allowed because minimum balance limit is 5,000. Similarly, let's say a customer, did a transaction because of which the total balance in the account went to 4,000. Now that customer then should be implicitly notified that the balance has fallen below the minimum balance limit of rupees 5,000, so that the customer can do the necessary action. Okay, let's move on to the next example. Every account number in the depositor relation must have a matching account number in the accounts relation. Now, considering the bank scenario again, there is always an account relation which keeps a track of all the accounts of all the different customers of the bank. And so basically this relation contains all account numbers, right? There cannot exist any account number which is not the part of this account and which of this relation, and that customer has anything to do with the bank, so that cannot happen. So then now those customers can either be some of the people can be the depositors, which either tend to deposit some money in the bank, or some of them could be the ones who have taken any kind of loan from the bank, right? The categories could be different, but we can for surely say that every account number in the depositor relation will always be present in the account relation. What I mean to say is that there cannot exist any account number in the depositor relation which is not present in the account relation. Now, this is also an example of very similar to the foreign key or integrity constraint, which we are going to see. It is also known as the referential integrity constraint or the subset condition, which we will see in detail in like towards the end of this session. So next, let's see the third example. It is no two accounts can have the same account number. So this is also very generic, very simple scenario, that yes, because account number is very specific to the account a person has in the bank, right? So every account is handled individually, independently from the others. So every account has a different account number, and that is why we always put the account number in the account relation as the primary key also. Okay, so it cannot happen that two accounts have the same account number. Okay, the account balance then cannot be null. This is also very generic or very simple to understand, that it cannot happen that the account, any account is opened with a null balance. No, it cannot be. Like every account is opened with any small amount of money, so it cannot be null. Okay, let's move on. So now let's see what are the different integrity constraints which can be applied on a single relation. So we'll talk about four generic ones first, and then we'll move on to the one of the most important ones, which is the referential integrity constraint. Why we have not put it in this slide is because in this case we talk about two relations and not one, but these all are linked to, these all can be applied on a single relation as well. Okay, so we have the constraint as not null, primary key, unique, and check P, where P is a predicate. Now over here, check P, check is basically a clause and it has this P as a predicate, which is basically a condition. Okay, we'll talk about these in detail and we'll take up them one by one. So let's start with the not null constraint, the first constraint. So first of all, why is it used or what is it used for? So it is used to avoid the default null value initialization for certain attributes. Now we all know that a null value is assigned many a times by default when we create a relation, but in some cases it may not be right to just initialize the attributes values as null. There can be some examples. For example, in an account relation, we cannot initialize the account number simply by null because most of the times we have the account number as the primary key, so they cannot be null. Also, also it is not meaningful to have a record which has uh, data values in different attributes, but the account number is null, right? So it does not make sense that there is an account which does not have an account number, but there is some money present against some person's name, so the account exists. So it simply doesn't make sense. Okay. Now similarly, account balance cannot be null. So in order to restrict, in order to avoid such scenarios of initializing such attribute values or attributes with null, we use the not null constraint. So we simply define in the relation itself, we define the attributes with the not null constraint. For example, here is the exact syntax. So let's suppose I need to make sure that account number is never set to null. So what I'll do is I'll define the account number. I'll write account number char 10. So that is the definition for this, and then I would say not null. So I would just write not null along with the complete create table name and everything. Okay, so I would just write account number. I'll give you the complete syntax, but for now this is it. And similarly for account balance, numeric 12 2. So account balance, it can have two decimal places, like the number of the balance is taken care of till two decimal places and 12 digits, and we say that not null. It can also not be null. And now what if a person tries to enter a record with a null entry? Then in such a case, or just avoids writing any value for that particular, let's say person tries to enter a record without any account number, then an error diagnostic is generated stating that you cannot put these values as null, or you have to give some value for these two attributes. Okay, now see in SQL, basically the null values are prohibited for the primary key of a relational schema, which I've already discussed in context of the account number as example. If I have to write a create table command using the not null, so I would write create table, let's say student. I would write student ID. Let's say I write it not numeric, I'll just take int. Student ID can be int, like some kind of roll number, right? And I say it can go to 3 digit. And now now we all know that student ID in this table will most probably be uh, the primary key, right? But if I say this is the record of the students in the entire uh, institution, then student ID alone cannot be a primary key. It has to be in combination with the department and other attributes maybe. So in that case, if I just want to make sure that this is not written null, I would just write not null here. Okay, and then I'll continue with all the attributes. And similarly, what if I wanted to, write the primary key constraint? I would write primary key. So this is after I've defined all the attributes. Let's say student ID, then I say department ID. Okay, I take char this time. Char, let's say 4. Okay, then student ID, department ID, what else? I would say city, let's say, and then I say char 20. Age, yeah, we can store the age as well, might be useful in some cases, I don't know. Maybe we can say 3, right? And then we say primary key, so there is a space between them. Let me just make it a bit clearer. Yeah, so I would write primary key, and then I would write student ID comma department ID. Okay, and then this is the closing bracket for this student tip. So this is how I have defined the student relation, and I have also specified the not null constraint and the primary key constraint. So this is how you do it. Okay, now let's move on to the next one, which is unique constraint. So what do we mean with this unique constraint? So unique, first of all, what is the syntax? Here is the syntax, unique, and then we have some attribute names, and we have separators as comma in this case. Now, what is the meaning then? What do we mean to say from here, right? It says that attributes A1 so on to till AM form a candidate key. That is, the combination of these attributes is unique. Okay. So now, what do I mean when I say the combination of these attributes is unique? I mean to say that this combination forms a candidate key. And now when I say that this combination forms a candidate key, we all know that the values, right? It cannot happen that if I take two tuples in the relation, then they have the same values, values for all the attributes of this relation. Let's take a quick example. Maybe we just discussed about the student schema, right? We have the student schema above. So we have student, we have student ID, we have department ID, and then we have, let's write in the same notation, we have city, we have age. Yeah, that's it. Okay, so now let's say I have, so what is unique in this case? We had the primary key as student ID, department ID. So I can say that unique student ID comma department ID, right? So now I can confidently say that student ID and department ID cannot, this combination cannot be same for any two students in the student table, right? So what do I mean to say is that, okay, we also had that name, na, student name, I didn't write. Okay, let's take another one, name over here, name char 20, because it will be easy to explain with that. Not that there is any that we cannot have the unique constraint in that. In this case, it is not that. I just wanted to have this to refer to to two students. Okay, so we have, let's say, Rahul, and we have another student, let's say Sheena. Okay, so it is not possible that both that Rahul and Sheena have the same student ID and department ID. That is, let's say they both belong to CSC department, then they cannot have the same student ID or roll number. Okay, clear enough, I guess. Okay, so this is what the unique constraint implies, and no two tuples in the relation can have the same values in all the attributes A1 to AM. I think we are clear about that. Now, candidate key attributes are permitted to be null. That we all know, right? Candidate key attributes should be unique, but they are permitted to be null until and unless we explicitly state that as not null, as I just did in this case. So in this case, I have explicitly mentioned that student ID cannot be null. Now, if I write the same for department ID, that it cannot be null, if I add the not null constraint over here, not null, then what happens? Then student ID, department ID combination becomes the primary key, which, as I've already written that primary key constraint over here, so by default department ID cannot be null. Okay, because in the primary key constraint, the unique constraint and not null constraint get combined. So when I say that a particular attribute or an attribute combination is a primary key, it means that the values of that attribute or attribute set means combination of attributes. So in that case, the attribute values can be anything, but they have to be unique and they cannot be null. The attribute cannot have a null value. Okay. And it is very important to note that a null value cannot be equated to any other value. We cannot say that two attributes have null value, so they are equal. No, null cannot be equated to any other thing, not even to null. We can't say that two attributes, let's say I say age and city, if they are null and I say age is same as city. No. Okay, let's move to the next one. We have the check clause now. So, first of all, I already said briefly that P is a predicate. Predicate implies that it is a condition. So, very basic form of it is that I can just simply say age is more than 5. That is a very generic form of a condition. Now, this we need to imagine in context of a relation. So, let's take the same example. Yeah, let's take the same example that we discussed in the previous case. So I can also apply if I want to, apply a constraint that the age of the students, let's say the student records, in the student records, I want to make sure that the age of students are more than 18. I'm only storing the records of the students whose age is more than or equal to 18. Then I would just say check age is more than or equals to 18. Now this has to be written during the create table, or we can later on add on this constraint as well. But if we are defining the table and at that point we want to write this check constraint, then where does it fall? Like, where is its place to write? So once you write create table student, and once you have defined all the attributes, right, student ID, age, city, so on, after that, after the definition of attributes, then is the place to write the constraints, and then finally we close the bracket for this create table thing. Okay, so then what is the common use? Common use is to ensure that attribute values satisfy specific conditions which are in the predicate. So all the tuples in the relation need to obey this condition for whichever attribute it is placed on. Like in this case, the attribute which is concerned is age. So in all the tuples, in all the student records, age should be more than or equals to 18. If I try to enter the record of a student whose age is less than 18, the database will not allow me to do so, and it will prompt an error message. Okay, next. So it can be applied in case of a relational declaration, as we've just discussed, or it can be applied in case of domain declarations as well. So let's take another example of relational declaration. We have create student table, name character 15 not null, so name cannot be null, and then student ID char 10, age into degree level char 15, and then primary key constraint. So we have the student ID as the primary key, and then check age is more than 15. So as you can see, the constraints only come after the definition of all the attributes in the create table command. Okay, then another check could be check degree level in bachelor's, master's, doctorate. So what do we do over here? We have provided with a list of values, and we are making sure that the degree level can only take the values from this list. So we cannot have any other degree level apart from these 3 degrees. Okay. So I think that's all for today, and we are going to take up the referential integrity constraint in the next session. I hope you find some content to learn something new today. In case you did, please press the like icon below and let me know your feedback in the comment sections below. I'll be back with another video on referential integrity constraints and the different versions with different variations and examples. Till then, stay tuned, keep learning. Thank you.